Weather and Climate, Part 1. Formula for temperature calculation. Mean daily temperature will be sum of hourly temperatures divided by 24. Diurnal temperature range, or you can say it as daily temperature range, will be maximum daily temperature minus minimum daily temperature. It is good for you to note that whenever you see the word range, it means maximum minus minimum. Mean monthly temperature, it will be sum of mean daily temperatures in the month over number of days in the month. Mean annual temperature, sum of mean monthly temperatures in the year divided by the 12 months. Annual temperature range, maximum mean monthly temperature minus minimum mean monthly temperature. There are four factors affecting temperature. The first is latitude. Latitude is the distance of any point on Earth measured north or south of the equator. This is your equator at 0 degrees latitude. Temperature differs between places at lower latitude and higher latitude. Earth tilts at 23.5 degrees on its own axis, so sun's rays strike various angles at different parts of the Earth. The solar angle is the angle at which the sun rays reaches the Earth. At higher latitude, the sun rays strike at lower angle. Solar energy is spread out over a larger area, leading to lower temperature. However, at lower latitude here, the sun rays strike at a high angle. Solar energy is concentrated at a small area, leading to high temperature. The tilt of the Earth on its axis leads to some places not receiving sunlight for months. During summer, North Pole is completely exposed to the sun's rays, receiving months of sunlight. The next factor affecting temperature will be altitude. Atmosphere is mostly heated by the Earth's surface. The higher the atmosphere, the further you are from the Earth's surface, which is heated by the sun. Hence, temperature decreases with increasing altitude. Another reason will be air at lower altitude absorbs more heat from the long-wave radiation. Solar energy enters the Earth as short-wave radiation. The Earth's surface absorbs some short-wave radiation and is heated up. It then gives off heat as long-wave radiation. Atmosphere absorb long-wave radiation, warming the Earth. Air at lower altitude absorbs more heat from long-wave radiation than at higher altitude because it is nearer the Earth's surface. Hence, temperature decreases with increasing altitude. Another point to note is air is more dense at lower altitude. Dense air absorbs more heat from long-wave radiation from Earth's surface, resulting in higher temperature. Another factor which affects temperature will be distance from the sea. Maritime effect is when large ocean bodies affect climate of coastal areas. During summer, air over sea is cooler than air over land because sea heats up slower than land. This lowers coastal areas' temperature. During winter, air over sea is warmer than air over land because sea cools slower than land. This increases coastal areas' temperature. So for coastal areas, they have cooler summers and warmer winters and a small annual temperature range. Let's look at the figure here. The coastal areas will be Anchorage, near the coast. Right, let's look at the summer. Okay, blue here, it belongs to Anchorage, the blue line. So your summer is here, below 15 degrees Celsius, and your winter is here, minus 9 degrees Celsius. So the winter is not so cold, so we call it warmer winter, and the summer is not so hot. We call it we call it cool summer. And the difference between maximum and the minimum temperature is not so large. So it's a small annual temperature range. Now let's go to continental effect. Continental effect is when continental surfaces affect the climate of inland areas. During summer, air over land is warmer than air over sea because land heats up faster than the sea. This increases inland areas' temperature. During winter, air over land is cooler than air over sea because land cools down faster than the sea. This lower inland areas' temperature. So for inland areas, they have warmer summer, colder winters, and large annual temperature range. Let's look at the figure here, Fairbanks. Fairbanks is located far away from the sea, so it is experiencing continental effect. The red line here belongs to Fairbanks temperature. Summer is at more than 15 degrees Celsius, and the winter is nearly minus 25 degrees Celsius. So it is true that they're having continental um, inland areas, they're experiencing very cold winters and warmer summers and large annual temperature range. Next, another factor that affects temperature is your cloud cover. In the presence of cloud in the daytime, clouds reflect large amount of sun's energy back to space. This keeps the Earth's surface cool. And at night, clouds absorb a lot of heat radiated from the Earth's surface and prevent it from escaping to space. This keeps the Earth's surface warm. In the absence of clouds, daytime, absence of clouds allows large amount of sun energy to reach the Earth. This keeps the Earth's surface warm. In the nighttime, absence of clouds allows a lot of heat radiated from the Earth's surface to escape into space. This keeps Earth's surface cool. Another element of weather will be rain. There are two types of rain. One is convectional rain and the other is relief rain. Let's look at convectional rain first. The sun's energy reaches the earth. The earth's surface is heated by the sun's energy. This in turn heats up the surrounding air. Number three, the air expands and rises when heated. Number four, as the air rises, it cools. Air reaches dew point temperature and condensation occur. Number five, cumulonimbus clouds are often formed. Number six, when water droplets become large and heavy, they fall to the ground as rain. Relief rain. Relief rain usually occurs at the mountain area. Step 1. Warm, moist air from the sea is forced to rise because it is blocked by the mountain. Number 2. Air cools as it rises. When dew point temperature is reached, condensation occurs and clouds form. When the water droplets are large and heavy enough, the rain falls on the windward side. Number 3. By the time the air moves to the leeward side, the air is dry and no rain falls. So here is your leeward side. Let's go to relative humidity, another element of weather. Relative humidity will be the ratio between the actual amount of water vapor in the air over maximum amount of water vapor in the air can hold times 100%. Air at 15 degrees Celsius with 5 gram per meter cube of water vapor but can contain maximum 10 gram per meter cube of water vapor. If you calculate, you can get your relative humidity at 50%. If actual amount of water vapor the air holds increases to 6 gram per meter cube, your relative humidity will be 60% instead. Now, what is saturation point? Saturation point when the air Saturation point is when the air holds the maximum amount of water vapor it can hold. Relative humidity. The ratio between actual amount of water vapor present in the air and maximum amount of water vapor the air can hold at a given temperature. So the formula will be relative humidity. Relative humidity is the actual amount of water vapor in the air over maximum amount of water vapor the air can hold times 100%. For example, the air is at 15 degrees Celsius with 5 gram per meter cube of water vapor, but can contain maximum of 10 gram per meter cube of water vapor. So when you calculate, you will get your relative humidity at 50%. If actual amount of water vapor the air can hold increases to 6 gram per meter cube, your relative humidity is 60% instead. Now, what is saturation point? Saturation point is when air holds the maximum amount of water vapor it can hold. This occurs when RH is 100%. The temperature at which saturation occurs, you call it dew point temperature. At dew point temperature, condensation starts to occur. If you look at this graph, it shows the amount of water in the air at 100% relative humidity at various temperature. For example, at 10 degrees Celsius, there is about 9 grams of water per kilogram of air, reaching saturation point. If you realize, the red color line shows 100% relative humidity, which is dew point. At 30 degrees, the dew point is here. If you look carefully, there is about 28 grams water per kilogram of air. At 50 degrees Celsius, the dew point is here. There is nearly about 95 grams water per kilogram of air. Now, what is the effect of temperature on relative humidity? If you look at this graph, as temperature decrease, your relative humidity increase. And as temperature increase, your relative humidity decrease. So we can say that relative humidity is lower at higher temperature and higher at lower temperature, assuming the actual water vapor in the air is constant. So what happens at higher temperature? At higher temperature, the air expands. When air expands, it can hold more water vapor. The air molecules are more spread out, so more water vapor can fill the spaces. When relative humidity is at 100%, more evaporation takes place. Clouds will be formed when dew point temperature is reached. Let's take a look at another element of weather and climate: air pressure. Isobars are lines joining places of equal air pressure on charts. If you look at isobars which are closely spaced, let's look at this area X. The isobars are closely spaced. This shows a strong wind, a place with strong wind. The pressure gradient is steep and it shows there is a great difference in air pressure between places. Let's look at isobars which are widely spaced, for example at Y. This shows a place with a weak wind. The pressure gradient is gentle and there is a small difference in air pressure between places. So what is air pressure actually? Air pressure is the weight of air molecules pressing down on the earth. It is measured in millibars using barometer. At sea level, the air pressure is 1013 millibar. If the air pressure is above 1013 millibar, the place is considered as high air pressure. If the air pressure is below 1013 millibar, then we shall call it low air pressure. So what happens at higher altitude? At higher altitude, the air is less dense because gravity pulls air molecules towards the Earth's surface. This lowers the air pressure. Air pressure is higher at sea level and lower at high altitude. Let's look at this graph. At 30-kilometer altitude, your air pressure is 0. As your altitude drops to 20, your air pressure increased to 15 millibar, or rather 75 millibar. Let's look at this graph. When your altitude is at 40 kilometer, your air pressure is 0 millibar. When your altitude drops to 20 kilometer, your pressure is close to 100 millibar. When your altitude drops to 10 kilometer, your air pressure increases to nearly 300 millibar. Next, let's go to wind. Wind is another element of weather and climate. Wind can be divided into two parts, which is breeze and monsoon. Let's go to breeze. There are two types of breezes. One is land breeze and the other is sea breeze. Let's go to land breeze. At night, the land cools faster than the sea. So, at land, we have lower temperature and higher pressure. And the sea, we have higher temperature and lower pressure. Warm air expands and rises, lowering air pressure over the sea. So because you know that wind is actually air that blows from high pressure to low pressure, so in this diagram, air moves from an area of high pressure, which is the land, to an area of low pressure, which is the sea, and they flow as a land breeze. Air cools and sinks. Let's go to sea breeze. In the daytime, the land heats faster than the sea. So on land, there's higher temperature and lower pressure. Air over the land surface heats up, warm air expands and rises, lowering air pressure over the land. How about at sea? Sea is having lower temperature and higher pressure. Air moves from an area of high pressure, which is the sea, to an area of low pressure, which is the land, as a sea breeze. So it blows from the sea to land. Air cools and sinks. Southwest monsoon. SAGI. S stands for Southwest monsoon, A stands for Australia, J stands for June, and I stands for India rain. In the middle part of the year, the northern hemisphere is having summer, and the southern hemisphere is having winter. So northern hemisphere during summer the temperature will be high and the pressure is low. For southern hemisphere during winter the temperature will be low and the pressure will be high. So air moves from Australia to India because air moves from high pressure to low pressure. Now, how does the wind blow from Australia to the equator? The air moves from Australia as southeast monsoon. How do we know it's southeast monsoon? Since we are flying towards India, your back is facing you. You are facing India. This is your left and this is your right. We know that in southern hemisphere, the Coriolis effect deflect wind to the left in the southern hemisphere. So your arrow goes to the left. Now, when your arrow goes to the left, if you do a compass here, you will know that this is actually southeast. This is the direction will be from southeast. So we call it southeast monsoon. Once it crosses the equator, the Coriolis effect deflects it to the right. The air moves as southwest monsoon. How do we know the south is southwest monsoon? At this arrow here, you draw a compass. So this here, the line here will be your southwest. That's how you got to know that the wind is blowing from southwest and you call it southwest monsoon. Now, the wind will pick up moisture over the Indian Ocean. Right? This is your Indian Ocean. And it brings heavy rain to India.
Next, let's go to northeast monsoon, which is NIDA. N stands for northeast monsoon, I stands for India, D stands for December, A stands for Australia rain. At the end of the year, the northern hemisphere is experiencing winter. So during winter, temperature is low, pressure is high. And southern hemisphere is experiencing summer. Temperature is high, pressure is low. So we know that the wind is blowing from northern hemisphere to southern hemisphere. So how do the wind blow? So if you are moving from India to Australia, you are facing Australia. Okay, this is you, you're facing Australia. This is your right and this is your left. Now we know that Coriolis effect in the northern hemisphere, right? It will bend the wind to your right. So your arrow, you move to your right. At this arrow here, you draw the compass. So from this compass, you know that this arrow is between north and east. So it's northeast. So the wind is blowing from the direction of northeast. So we call it northeast monsoon. That is why we say air moved from India as northeast monsoon. The wind is very dry and cold. Why is it dry and cold? Because it's blowing over the continent. Right? And it blow across cold land. Now, once it reaches the equator, the Coriolis effect will deflect the wind to the left. This is your left. How do you know this is your left? You see here, this is you, this is your right, this is your left. So this is your left. And the arrow here, draw the compass, and this is your north, this is your west, so this is your northwest monsoon. The wind is blowing from the northwest, and we call it the wind as northwest monsoon. So hence, air moves as northwest monsoon and picks up moisture over the Indian Ocean and bring heavy rain to Australia. Now let's go to clouds. When Earth's surface is heated up, water is evaporated and converted to water vapor. When water vapor rises, it starts to cool. When it cools to dew point temperature, condensation occurs. During condensation, water vapor forms tiny droplets around dust particles in the air. These dust particles, we call them condensation nuclei. The short form is CN. Water droplets will bump into each other and become larger. Coalescence process. Billions of water droplets come together to form clouds. When these droplets grow large enough, it falls as rain. If you look at this diagram, this is a water vapor in the air. Condensation nuclei provides surface for droplet formation. So water vapor is attracted to the dust particle. Another word for the dust particle is condensation nuclei. Let's go to the three types of climate. The first is the equatorial climate. Let's look at this climograph. Now, this is your rainfall and this is your temperature. Where is the distribution of the equatorial climate? Areas close to the equator, because the sun's rays are concentrated over these areas between latitude of 10 degrees north and south. For example, Central and South America, Southeast Asia and Africa, Singapore, Malaysia, Congo, and Brazil. Now, what's the characteristic? It's high temperature due to the high angle of incidence of sun rays. The sun rays are more concentrated at the equator. High mean annual temperature at 27 degrees Celsius. Small annual temperature range, 2 to 3 degrees. Let's look here. The maximum is about 28 and the minimum is about 26.5. So the annual temperature range is small, 28 minus 26.5. which is about 1.5 degrees Celsius. Now, high relative humidity, which is 80% throughout the year. Total annual rainfall is about 2,000 millimeters, which is high. And convectional rain. We have no wet or dry seasons. The next climate will be the monsoon climate. Where are they distributed? It is between 5 degrees north and 25 degrees north and south of the equator, for example, India, Sri Lanka, and Vietnam. The characteristics high temperature, high rainfall, and high humidity throughout the year. We have distinct wet and dry season for monsoon climate. If you look at this climograph, this is your distinct wet season and this is your distinct dry season. Because these areas are affected by the monsoon wind. Higher rainfall, middle part of the year, and lower rainfall, end and beginning of the year. Temperature range is moderate. Okay, maximum minus minimum. Temperature range is moderate, about 7.5 degrees Celsius. Lower mean annual temperature than equatorial climate because they are located further from the equator.
Cool temperate climate. They are located away from the equator. Cool temperate climate. Countries with cool temperate climate are located away from the equator. They are located between 45 degrees and 60 degrees north and south of equator. Example, France and Canada. The characteristics will be mild winters, cool summers. Right, let's look at the temperature. The winter is below 20 degrees Celsius with mild winter. Sorry, cool temperate climate. Countries with cool temperate climate are located away from the equator. They are located between 45 degrees and 60 degrees north and south of equator. Example, France and Canada. Usually, these countries with cool temperate climate have mild winters and cool summers. Let's look at the temperature in the climograph here. The summer is slightly below 20 degrees Celsius and the winter is about slightly below 5 degrees Celsius. So it's mild winter and cool summer. Rainfall evenly distributed, but total annual rainfall is lower than in places with equatorial and monsoon climate. Large temperature range of 25 degrees Celsius. They have four seasons because of the revolution of the earth around the sun. Temperatures are high in summer and low in winter. This results in large annual temperature range of 25 degrees Celsius and the lower temperatures than places near equator due to high latitudes. Temperatures are lower at higher latitudes because of the sun rays strike at a lower angle and solar energy is spread out over a wider area.